Alright, in this video we're looking at divisibility induction. Now, a quick reminder about what induction is. It's a method to prove statements true for various different n values. Usually these n values are positive whole numbers. And an example of the statement we'll be proving looks something like this. So this one here says 6 to the n plus 4 is divisible by 5. That means that we're trying to prove that no matter what value you put in for n here, the answer you get will always be divisible by 5, with n being a positive whole number here. Alright, so the example we're doing in this video is 7 to the n plus 2 being divisible by 3. Now, this can be a bit annoying, this part, but we do have to start by saying let Pn be the statement. And then we say 7 to the n plus 2 is divisible by 3. Unfortunately, with induction, there is quite a bit of writing involved. All right, so what we need to do is step 1. So we need to check the base case n equals 1. So we're just going to be looking at P1. So 7 to the 1 plus 2 is 9. And then we can say is divisible by 3. And then this is where the notation that we set up sort of here helps us out a lot, because then we can just say, therefore, P1 is true. P1 is true. Okay, if you want, and if you're having trouble with induction, you can actually check 2, 3, 4, 5 even if you want, and that should give you a feel for how the proof is going to work. So it's not a bad idea to do that, but formally we can just leave it at P1. All right, so next we're going to do the PK steps. This is step 2. So assume 7 to the k plus 2 is divisible by 3 for some k in z plus. All right, now this set z plus, this is the positive integers. So z is whole numbers, and then the little plus makes it positive. And if I can get it to work, z should look like it's got 2 little bars there. All right, so what that means, and the little tip that I've given you in the topic booklet up here, is that we want to write it like that. So we want to write 7 to the k plus 2 is 3 times some whole number a. A just has to be in z. Now, really importantly, a could be negative here as well. And if we rearrange that, which is a good idea, 7 to the k is 3a take 2. Now, I'm going to call that a little star there, and you'll see why I do that later. It will help us sort of refer back to this with notation. Okay, so now we're going to do the pk plus 1 step. Okay, so we're going to be looking at 7 to the k plus 1 plus 2. Now, I'll often in induction do something called a want to show. What are we trying to prove here? And then we'd like to show that this thing is divisible by 3. So I'll just make a little note of that off to the side here. Okay, so how do we do this? Well, we just split it up. So it's 7 to the k times 7 to the 1. So that's index laws plus 2. 7 to the k is 3a take 2. And then this can be from star. Now, if you're not familiar with this little dot, quite often the dot there will mean to times, so just be aware of that. Okay, then we just expand it out. So probably easiest if I write it like that, and then I FOIL it in. So I've got 7 lots of 3a, so that's 21a. Take 14, just like that. Okay, and then we can just collect like terms. So I've got this 21a term, and then it's just going to be taking away 12, just like that. Okay, beautiful. So if we're trying to show that something's divisible by 3, what does it mean for it to be divisible by 3? Well, it means that it's 3 times some whole number. So if we can pull out 3 as a common factor here, we're done, and indeed we can. So I'm left with 7a take 4. Now, it's pretty important to explain here that this thing here, so 7a take 4, that actually is a whole number, and it's really important to mention that, as a is in z, just like that there. Okay, now, therefore, pk. Well, therefore, and we can actually say the statement here, 7 to the k plus 1 plus 2 is divisible by 3. Therefore, pk plus 1 is true. Okay, so we've done that. Now we've actually done the induction proof because we've done all 3 steps. So I won't get too much into how induction works here, but doing all 3 of those steps confirms that, yes, this is going to be true for all positive whole numbers. So therefore, 7 to the n plus 2 is divisible by 3. For all n in z plus. And then usually we say, just before this, by induction. All right, beautiful. Okay, there's a couple of follow-up parts, and this is what you can expect to see in like an induction exam question here. So 7 to the n take 1 is divisible by 3. So it's just worth mentioning. So 7 to the n take 1. That's the same thing as what we had before, take away 3. Now, why have I written it like that? It's because this is divisible by 3 from part A. So really, therefore, 7 to the n plus 2 is like 3 times some whole number b. That's what it means to be divisible by 3. All right, beautiful. Okay, so let's have a look here. So we can write this as 3b take 3, and then we can pull out the common factor of 3. And then this thing here is in z as b is in z. And then we can just say, therefore, 7 to the n take 1 is divisible by 3. So the core argument here is that if 7 to the n plus 2 is divisible by 3, then if I, subtract 3 from it to get 7 to the n take 1, that will also be divisible by 3 because it's 3 away from something divisible by 3. That's essentially how that bit works. Okay, part C for this question is quite nasty. It's showing that these things are divisible by 9. The thing that you should always do in an exam style question is try and use your previous parts. And what you might notice is that if I do 7 to the n plus 2 and 7 to the n take 1, and we FOIL it out, so I'm going to get n plus n there for that bit. I'm going to get 1 times 7 to the n and 2 times 7 to the n, and then take 2 at the end. So I'm going to get 7 to the 2n plus 7 to the n take 2. Oh my goodness, that's what we got. So we can actually sort of work in reverse here. So we can say, therefore, 7 to the 2n plus 7 to the n take 2 is 7 to the n plus 2 and 7 to the n take 1. And this can be, let's call it 3c times 3d. And then we can say c and d are whole numbers. And then this actually comes from A and B there. Okay, 3 times 3 is 9. So this is 9CD. And then this thing is a whole number too, as C is a whole number and D is a whole number. And then we can just finish that off. So therefore, 7 to the 2n plus 7 to the n take 2 is divisible by 9. Cool. All right. One little thing I should just pop back up the top. Usually with a proof, we will end with a little square. You can also write QED, or you can write as required if you prefer. So a little colored in square is what I do, mainly because it's quick to write down. Cool. All right.